Good morning. It's good to be here at EcoBuild in a newer venue. Not sure quite how eco is anymore, but it's just getting bigger and bigger every year. But I'm here to talk to you about urban food, and we've been playing with growing food in vertical applications on our BioTecture system. And we have, in fact, a wall just over there of demonstration of young salad and herb plants growing. But I want to address the wider issues of why this is necessary. And to do that, we have to look at the sort of global picture a bit and understand a bit about food and where things are going. So the first and most obvious question is, well, why farm in urban areas? They're not ideal. They're full of buildings, they're full of pollution, they're full of people, there's no ground space and everything. So we've got all the countryside around. So why farm in an urban environment? Well, the reasons are basically ones of ecology and sustainability and sort of bringing our planetary and population systems back into balance. We have exponential population growth going on globally at the moment. We're at nearly 7 billion people now. By 2050 we'll be up at 9.5 billion people. That is a colossal growth of human population, all of which has to be fed and watered, and every individual requires resources, and we're already on a planet that's straining into overload. So how do we accommodate and deal with that? Of that population, 50% of it is now urbanised, so living in urban centres on just 2% of the land mass. But that's going to grow to 80% by 2050. So the vast majority of the population on the world will be in urban centres. In the UK, we're already 80% urbanised and have been for quite a long time, but the rest of the world is catching up fast. There are problems that are compounding upon themselves, and one of the biggest is water use. We are rapidly exhausting the easily available supplies of water that we have on the planet. You can never put water out of use because it's essentially a closed loop. You can never water because it's essentially a closed loop system globally, but you can put it beyond use, and that's what we're doing. We're draining our fossil aquifers rapidly. We're drying up our hydrological cycles. So water is becoming a big issue. Not only that, but our modern agricultural system that feeds us currently is based heavily on the use of fossil fuels. It is grossly inefficient in terms of energy use. For every calorie of food energy you eat, at least 10 calories of fossil fuel energy have gone into its production. We're sitting at a world where we're reaching the global peak of oil production and supply. Oil is going to get more and more expensive and in shorter and shorter supply. You only have to realise that oil is back up at over $100 a barrel, or was a few days ago, to realise that the implications of what happened the first time we reached over $100 and sent the world into global recession. So energy is going to be a crucial issue, and combined with that is the fact that every item of food you eat has travelled on average 1,200 miles to get to the supermarket shelf. Every single thing you pick up, 1,200 miles of transport. When the recession first hit a few years ago, we saw transport companies going to the wall left, right and centre. We saw airlines going. We base all our food production on just-in-time supply, and that just-in-time supply system is very, very fragile. It is based on the cost of oil. So those are all underlying reasons why we have to look at growing food where the people are, and the people, as I've already said, are largely in urban centres, and increasingly so. We have to find ways of producing food on people's doorsteps. So what do we do? Well, basically we have to change the world from linear growth methodologies to cyclical. growth or cyclical systems. This is not new stuff. It may come as surprises to us all, but it was documented very well back in the 70s with the Limits of Growth document that was produced by the Club of Rome. The linear growth inevitably means you're going to run out of resources one end and end up with a huge pile of rubbish the other end, because that's how it works, like a conveyor belt. We just produce, consume, dispose. That is a system that is stripping the planet of its capital resources. We've been outstripping the capital resources since the mid-1980s. Cyclical growth is the only kind of growth that can be sustained, because it works within a balance and has a sort of overall stasis about it. We can't have... Governments right now are scrabbling to get back to sustainable growth. There is no such thing unless it is cyclical. So I use this to explain what a cyclical system is. This is basically the nitrogen cycle. It's nature's method of recycling waste. And this is an example of how a biofilter works in a pond. And I'll show you, for example, this is a pond with a biofilter in. It's one of my old landscape projects. But I'll come back to this. In that pond we have fish, and the fish swim around and they eat food, and they excrete waste into the water. And that waste that they excrete is pollution, because it rapidly turns into ammonia. Ammonia is a pollutant to us. To our human thinking, we have to throw resources at it to remove that pollutant. Except to nature, that's not a pollutant, it's an output. It's an output from that fish, and it's an input into something else. And that something else is bacteria. And that bacteria, there's a bunch of nitrosomonas there, they like ammonia. They grab hold of that ammonia and they eat it as their lunch. So great, they get rid of the ammonia. Brilliant, it's gone. But like anything else, they have an input and they have an output. And they output nitrites. And nitrites are not much good to us either, because they're a pollutant as well. And those pollutants, yeah, it's a problem. It's another pollutant. But it's not a pollutant, it's an output. And that output is an input into another set of bacteria that live next door to the other ones. And they like nitrites and they eat those for lunch. And that's great, it gets rid of the nitrites. But they also have an output. Their output is nitrates. Nitrates is essentially nitrogen. So living next door to them are these guys, plants. And those plants take those nitrates and they turn it into green growth. They take the sunlight, they take the nitrates, they turn it into growth. So they turn pollution into growth, beauty, productivity, but they also return clean water back to the fish. That is nature's closed loop cycle. That is how every single system on this planet has to work, with those principles, if we are to survive and have a sustainable future. If we carry on doing things in a linear, we'll run out at one end and we'll suffocate in the crap that we pile up at the other end. So that is the principle of cyclical systems. So here, as I said, there's a filter. See, that water is pumped through this filter, rises up through the gravel where all that bacteria live. They do all their work, turns the plants grow, they're lush, beautiful, they could be productive plants. But you can take that biomass off, compost it, put it back into a fertility cycle, return clean water to the system. Cyclical thinking. And that is essential to all future food production. None of our food production at the moment is cyclical. Even most organic farming is not cyclical. It is still done in a linear manner with external inputs and external outputs. So what's the future look like? Well, it doesn't look like this. Okay, you get a lot of architects getting really excited and coming up with these fantastical schemes. It's a load of bollocks. Schemes like this are just fantasies to people's egos, all right? We can't afford the embedded infrastructure, the embedded energy that go into these glorifications. So that is not our sustainable